evening everyone. Welcome to my class. This is the second class in Karnataka TET 2024. The topic is motion. This is the second class in the topic motion. Those who are not watched the first class, please go through the first class. Few important questions we discussed in the first class of the chapter motion. Once again, 1 minute, I will check that one. Okay, last class I discussed the same question. Once again I will discuss this question, then I will move to the next question. If the force applied to a body is doubled, the force is double, F, it will become 2F. Then mass is cut off, M, it will be 1 by 2 M. Then what is the acceleration ratio? A1, A2 acceleration ratio they are asking. Let us consider first A1, it will be F divided by M. Second one, it will be 2F divided by M divided by 2. Let us cross multiply this one. F by M into reciprocal of this one, it will become, otherwise you can cancel directly here, you will get 1 by 4. That is the easiest one. Cancel it here. See, F it will get cancelled, M it will get cancelled, then 1 by 2 it will become reciprocal, it will move up, it will become 2, 2 2s are 4, therefore the ratio it will be 1:4. Simple simplification here, the force is doubled, then mass is cut into half. That is the important one they are asking here. And let us move to the next question. Very important questions. Question number 8. On a flat surface, a block of wood is placed. To move the body, a force is provided parallel to the surface. The frictional force developed in the following directions. Option A, normal to the surface upward. Option B, normal to the surface downward. Option C, along the applied force direction. Option D, opposite to the applied force direction. The correct answer it will be option D, opposite to the applied force direction. Already you know, if the body is moving in this direction, the frictional force it will be always opposite to the applied force direction. See, to make a body to move, then you have to apply a force. If the force is applying in this direction, then the frictional force it will be opposite to the applied force direction. Very important and also easy question. Then next question. On the roof of a train traveling on a horizontal rail, a simple pendulum swing. If the pendulum string is pointing towards the front, the train is option A, moving at a steady speed. Option B, moving with acceleration. Option C, moving with retardation. Option D, at rest. Understand the question. The correct answer will be moving with retardation. What is mean by retardation? Retardation, it will be the negative acceleration. See, the change in velocity is referred to as acceleration. The positive acceleration occurs when the body velocity increases. Similarly, as velocity decreases, the acceleration become negative is called retardation. When acceleration, when it is negative, when acceleration, when you will get a negative value, that one we will call it as a retardation. Retardation means when there will be a decrease in the velocity of the object, the acceleration it will be negative. Negative acceleration, another word we will consider as a retardation. That is the important one. Here, once again I will read the question. On the roof of a train traveling on a horizontal rail, A simple pendulum swing. If the pendulum string is pointing towards the front, the train is moving with retardation. Means the train is moving with uh, decrease in velocity. The decrease in velocity, it will indicate acceleration, it will be negative. Acceleration is negative means the train is moving with retardation. Next question. Question number 10. Unless driven to act otherwise by an external force, every body remains in its condition of rest or uniform motion along a straight line. This is the option A, inertia law. Option B, Newton's first law. C, both A and B. Option D, none of the above. Both A and B. Newton's first law, inertia law, everything both also same. If a body, if it is moving continuously or if it will be at rest, then that object, it has to be in the same position, otherwise it will be in the same motion. Let us move to the next question. If a body net external force is 0, it has a option A, 0 velocity, option B, 0 acceleration, option C, non-zero acceleration, option D, none. If a body net external force is 0 means it will experience a 0 acceleration. Next, what are the components required to calculate the momentum of a body? What is needed to calculate the momentum of a body? Option A, mass and acceleration. Option B, velocity and mass. Option C, displacement and mass. Option D, none of the mentioned. Option B, velocity and also mass. Momentum, it will be m into v. According to the formula, you can conclude momentum of a body, it will be depends upon velocity and also mass. These questions are easy questions. These are 9th, I think 8th or 9th NCERT questions. 13th, the quicker the momentum changes. Option A, the force is less. Option B, the force is greater. Option C, the force is 0. Option D, there is no force. The quicker the momentum changes. If the momentum is changed fastly, then what will be the force? The force, it will be greater. When it will be the momentum, it will be more. Otherwise, when you will observe a change in the momentum, sudden change in the momentum, then there will be a greater force. Next question. Question number 14. A body's rest of change of momentum is option A, inversely related to applied force. Option B, directly related to applied force. Option C, does not depend upon applied force. Option D, none of the mentioned. Rate of change of momentum is directly related to the applied force. Directly related to the applied force. How much force you are applying, F is directly proportional to the P. F is directly depend upon the P. Next question. 15. The rate at which a body momentum changes is proportional to the force applied and occurs in the direction in which the force is applied. This is option A, Newton first law. Option B, Newton second law. Option C, law of inertia. Option D, third law of motion. Yes, F is equal to ma, that is Newton second law of motion. Next question. There is an opposite and equal reaction to every action. This situation is described by option A, the first law of motion. Option B, second law. Option C, law of inertia. Option D, third law of motion. Yes, for every action there is an equal and opposite reaction. That is Newton third law of motion. Very easy questions. Okay. Next question. The component of a contact force that is perpendicular to the surface in contact is referred to as. Option A, frictional force. Option B, normal reaction force. Option C, both A and B. None of the mentioned. Then option B, normal reaction force. A component of contact force that is perpendicular to the force. If anything is perpendicular, already I told it should be normal. Therefore, normal reaction force. Next, what will be the displacement of a particle moving along a circular path of radius r after a displacement of half of a circle? See, this is the circle, this is the center, this is the radius, then this is also one of the radius. Half of the circle, the displacement it will be, this is the displacement, it will be 2 into r. Displacement of half of a circle is 2r. They are talking about the displacement from here to, from A to B, half of the circle. If they consider the displacement for a full circle, then displacement it will be 0, but they are asking the displacement half of a circle, it will be 2r. Next, I think these are NCERT questions, easy questions. Next one, the path length travelled by a body in a given time interval is known as distance, velocity, acceleration, momentum. The path length travelled by a body in a given time interval we will consider as a distance. Yes, let us move to the next question. Which of the following situation is true and also possible? Option A, if the velocity of a body is 0, the acceleration can be non-zero. Option B, a body moving at constant velocity, then it has a acceleration. Option C, the magnitude of distance and displacement are equal in a circular motion. All of the above. The correct answer for this question is option A. If the velocity of a body is 0, the acceleration can be non-zero. See, if a body is moving with, if the body is possessing the velocity, if the velocity of the body is 0, then don't think that body is not accelerating, it is not experiencing any acceleration. Always there will be a minimum amount of acceleration, always it will be there, even the body possess velocity is 0. That is important point. Next question, velocity is defined as dash per time. A very easy question, displacement per time. Velocity is nothing but displacement by time. A body moving in a straight line has a uniform motion if it is travels dash distance in equal interval of time. Equal distance in equal interval of time, that is only we will consider as a uniform motion. That is the definition of uniform motion. Very easy question. Next question, suppose a body is moving with a uniform velocity 10 meter per second on a merry-go-round ride. Which of the following is true of the given scenario? Option A, the body is at rest. Option B, the body, Option A, the boy is at rest. Option B, the boy is moving with no acceleration. Option C, the boy is moving with accelerated motion. Option D, the boy is moving with uniform velocity. Option C, it will be the correct answer. Suppose a boy is moving with uniform velocity. The velocity is uniform, that is 10 meter per second. Then that boy is moving with accelerated motion. Already the velocity is, even though velocity is uniform velocity, then you will find there will be a accelerated, that body, that boy, he will possess a accelerated motion. Next question, what does the slope of the distance time graph give? In the distance time graph, the slope it will indicate what? Option A, speed. Option B, velocity. Option C, acceleration. Option D, displacement. The correct answer is A. that it will indicate a speed. In the same way, the slope of velocity time graph gives option A speed, option B velocity, option C acceleration, option D displacement. It will gives acceleration. Both questions also very important. The slope of distant time graph, it will indicate a speed. The slope of velocity time graph, it will indicate a acceleration. Most important question. Option 9. Which of the following is true of a free falling body? Option A, it moves with non-uniform motion. Option B, it has zero velocity. Option C, it has constant non-zero acceleration. Option D, it has non-uniform acceleration. Option C, it will be the correct answer. Which of the following is true when an object is free falling body? It has a constant non-zero acceleration. Yes, free falling body, because of the earth gravitational force, it will move towards the earth. It will experience a constant non-zero acceleration. Next question. The physical quantity that has both magnitude and direction we will consider as a vector. Very easy question. Which of the following is not true for an object moving along a straight path in an accelerated motion? Option A, its velocity always changes. Option B, its speed keep changing. Option C, it always goes away from the earth. Option C, it will be the correct answer. Which of the following is not true? They are asking. If your body is moving along a straight line, then you will observe the velocity, it will be changes, speed, it will be changes, acceleration, everything it will change. But here they are, which one is not true? They are asking. It always goes away from the earth. They are not indicating the direction. How we will tell go away from the earth, whether it will be moving towards the earth, that we don't know. Next question. The inertia of an object causes the object to A, decrease its speed. Option B, increases its speed. Option C, resist any change in the state of its motion. Option D, decelerate due to friction. De-accelerate, I think. Option C, it will be the correct answer. De-accelerate due to friction. Decelerate. Okay. The correct answer, the inertia of an object causes the object to resist any change in the state of its motion. Inertia, the word itself indicating the object, it will be at rest. To overcome the inertia, you need some force. Without applying any force, the object, it will not come out from the inertia. Resist any change in the state of its motion. Let us move to the next question. Which of the following is true for the third law of motion? Option A, action-reaction pair always act on the same body. Option B, they act on different bodies in opposite directions. Option C, action-reaction pair have the same magnitude, directions. Option D, act on either body at normal to each other. The correct answer will be they act on different bodies in the opposite direction. That is the which of the following is true for the Newton's third law of motion? They act on different bodies in the opposite direction. See, because action and reaction always act on different bodies in opposite direction, and also they will be equal in magnitude. Simple, Newton's third law of motion. What is the SI unit of force? Kg meter per second square. Option B, kg meter per second. Newton meter, Newton. The correct answer will be SI unit of force is Newton. Next question. If the mass of a body is doubled, m, it will become 2m. Okay. Its velocity, it will become off. Then the linear momentum of the body. Option A, become double. Option B, remains the same. Option C, become off. Option D, become 4 times. it will be remains the same. Whether the mass of the object, velocity of the body, it will be changes also. Linear momentum of a body, because linear momentum of a body is directly depend upon the force. It will not depend upon the mass and velocity. Especially I am talking about the linear momentum. Linear momentum of the body is not depend upon the mass and velocity. If you will observe any changes in mass and velocity, linear momentum, it will be remains the same. Last question. Linear momentum of an object is 250 gram centimeter per second. If the velocity of the object is 5 meter per second, then the mass of the object, you know. Consider velocity. Velocity, it will be 5 meter per second. Then linear momentum, P, it will be 250 gram centimeter per second. Converted to meter, it will become, yes, better substitute, okay, leave 250, okay, velocity we will consider. Velocity will be 5 meter to consider centimeter, 100 centimeter per second, it will be 500 centimeter per second. Because momentum, it will be in centimeter per second, therefore velocity also convert in terms of centimeter per second. Then you know the formula. Mass, it will be momentum divided by velocity. Momentum is 250, then velocity, it will be 500, then 1 by 2 is nothing but 0.5 gram. Mass, it will be 0.5 gram. Very easy problem. Only you have to remember here, you have to convert velocity in terms of centimeter per second, because here momentum, they are given in centimeter per second. Next question. Which of the following is true about force? Option A, force is invisible. Option B, force can move a body. Option C, can deform a body. All of the above. The correct answer, it will be all of the above, because the force is invisible. Force can move a body. If a body is at rest, if you apply a force, the body, it will move. Force can deform a body. Force can change the shape of the body also. Yes, last question. A goalkeeper in a football game pulls his hands backward after holding the ball shot at the goal. This enables the shopkeeper to, option A, increase the rate of change of momentum. Option B, decrease the rate of change of momentum. Option C, increase the force exerted by the balls on the hands. Option D, exert larger force on the ball. A goalkeeper in a football game pulls his hand backward after holding the ball shot at the goal. What will happen? You will observe in a goalkeeper, when he will catch the football, then he will move his hands back when he is catching the football. Why it will happen? Why he will do like that? To decrease the rate of change of momentum. Otherwise, it will hurt its hands. Even he will get hurt. To decrease the rate of change of momentum, then the goalkeeper in a football game pulls his hand backward after holding the ball. Yes, next question. Which law is also known as law of inertia? Very easy one. Newton's first law of motion we will consider as a law of inertia. Then, yes. Next question. A passenger in a moving train tosses a coin that falls behind him. It means that the motion of the train is A, uniform, B, accelerated, C, retarded, D, along circular track. It will indicate the motion of a train, it will be accelerated, because when a train is moving, then you will observe a change in velocity. Change in velocity, it will generate the train, it will get accelerated. Okay. Okay, thank you everyone. Thanks for listening my class. This is the second class in the topic motion. Okay, today at night I will upload the theory part of the motion. Please go through that video also. Then this is the second part. Please watch motion first part video also. There I discussed few MCQ questions. Okay, and also those who are watching without subscribing to my channel, please subscribe, and also tell me your feedback, which type of classes you need, which topic you need, then anything feedback, whether you are following my class or not. Tell me your valuable feedback. Definitely it will help for me whether I have to continue, I have to make the classes or not, whether the classes it will be helpful for you or not. Everything I can know. Otherwise, without feedback, blindly I am taking the live classes. I don't know the feedback. It will be very difficult for me. And also you need, whether you need GK classes or child development classes, even maths also I am going to start. Even child development also I did one class. Tomorrow I am going to take one more class. GK I will take, computer I will take, child development I will take, even maths, science, everything. Now onwards, at least daily one classes I will take. And also even when I am free, I will upload the videos also, recorded class also I will upload. Please watch that classes also. And also thank you everyone. Thanks for listening my class. Please tell me your feedback. It is very important for me. Okay. Thank you everyone. Thanks for listening my class.